It's a bit quiet now. Welcome everybody to workshop number 2. Today we'll be going over more of the advanced stuff. So Jamie will first do how to deploy your model onto Azure, and then Shaman will do some more advanced machine learning stuff with transformers maybe. And then Michael and Sakya will go through the bot framework stuff, and then we'll hopefully have lunch sometime in the middle. So first up, Jamie. If you have any questions about MSA or the assignment, just let one of us know. There's probably enough of us around. So Jamie, you want to do your...
Oh yes, so since we're doing model deployment, do you guys have the GitHub and stuff on your computer? Yep, okay, sweet. Yeah, so while I'm setting this up, I guess you can have a look and start reading the README, and maybe you can go on Azure and try set up kind of the machine learning module that you will need. So make sure your account has like the Microsoft student subscription as well, because it'll cost money to use the service. Okay, sweet. So I've set everything up now. So at the beginning, so for part of your MSA assignment, you'll need to train a machine learning model that does the predictions of the readability of some text. So once you create this model, one of the advanced requirements that we set was to deploy it on Microsoft Azure. So what that means is that with the model that you trained, host it on the remote server, like the cloud, and then that you can get an API to access that model and make API requests and get data. So what we'll be using is the Microsoft Machine Learning module. So what you need to first do is set that up on your Microsoft Azure account. So I'll walk through that as well right now. So go to the Azure portal and log in. Sweet. So now we can create the machine learning module. So just in the search bar, type machine learning, and click the first thing that comes up. And there should be like a create button here that you can create the resource. So click on that. And if you have the student subscription, it should show up here. Otherwise, I don't think it will let you create the machine learning resource. So make sure I think most people have that set up, right? Yeah. Sweet. So in the resource group, you will probably create would probably be empty for you guys. So you will need to click create new and just give a name. So for this, I'll just do maybe like MSA example deployment. So when you're doing your assignment, just name it something that makes sense to you so you can keep track of what you're doing. And for the name, I might just keep it the same as well. Sweet, and now it should be done. You can just go click Review and Create. Sweet, and then Create. Yep, so now Microsoft Azure is just like setting up everything for you, and we just have to wait a bit. So is everyone good so far? Sweet, so once it finishes deploying, you can click on the resource and it should open to this page. If you click Launch Studio, this will take you to the machine learning studio thing that you just created. So in here, you can do a lot of things. You can do your Python notebooks and create machine learning pipelines as well. But we won't be doing that. We just need to do the model deployment part. So when you deploy a model, it will show up in your model list. And then when you deploy it, it will have its own endpoint. And that endpoint you use to call for the other advanced features that you might want to implement. So now that this is set up, we can go back to this page. And you should see this download config.json file button. So you click this to download the configuration file that you would need to use. Yep. So once we download that, it's to save it somewhere. So we can now navigate to the example Python notebook. So that should be in the repository on the example, and then this example notebook. So is everyone able to open this up? So for you guys, you'll probably open it on your computer, since my computer wasn't able to connect to the lecture recording, so I'm just doing it on Google Colab. You could do the same if you want. So in that case, you would just download the notebook file, this one, example.ipynb, and then open a Google Colab, and then you can upload onto this. So I'll just wait till everyone sets this up on their computer.
Which folder that's in again?
Oh, yeah. It's all good. So in the model deployment folder, you should see like in a folder called example. Yeah, and then there'll be a file called example. Yeah, and you can download that one. Sweet, is everyone ready to go? Okay, sweet. Okay, so since we have the notebook open, we can kind of start working through the example. So what I've done in the example is just train a really simple XGBoost model on the Iris dataset. So the Iris dataset is something that most beginners will look at. So this is just an example. But what you would do in your assignment is in the model training part, which is kind of what we covered last week. We downloaded the data from Kaggle. We used also XGBoost as well. We split the data into a test and train, and then we trained the model. So this should be something that you will have to work on your own and figure out, a good way to process the data and then train a good model that will work really well. So for this example, I just trained it on the Iris dataset. So we can run the first chunk of code to just load the packages in. And then this chunk of code is just loading the dataset in as well. And then this is the training part. Oh, no, this is splitting into a test and train part. So we do that as well. And then this over here trains the model and then saves the model as a JSON file. So in your assignment, you'll probably do something similar. You'll probably train the model, and then you'll have to save the model to some file. If you're using XGBoost, you probably do something real similar to this. But one of the advanced requirements was to train a Hugging Face model, which we'll cover later. When you save that model, it outputs a folder with a lot of different files. So you got to be aware of that. So depending on what type of model you're training, the type of file that you save will also be different. So you got to be aware of that. Okay, so now that we've kind of trained the model and then saved it somewhere, we can now deploy the model. So this is the main section that I'm covering today. So before I downloaded that config JSON file. So that file allows us to connect to our to the workspace that we made before. So since I'm doing it on Google Colab, I have to upload the file into the Google Colab file section. But if you're doing it locally on your computer, you can just save the config JSON file in the same directory as your notebook. So since I'm doing Google Colab, I will upload that onto the Google Colab file storage. Okay, so assuming you guys have done that as well, we can connect to our workspace. This is what this chunk of code does. Oh, yeah, so before you do that, you have to make sure you have the Azure ML core library installed. So I can show that as well. So for you, if you're doing it on your local machine, you just open up a terminal and type pip install Azure ML core. And if you're doing it on the Google Colab, you can copy and paste what I've just done here. Sweet. And then we can try load the workspace. Yep, so when you try to connect to the workspace, if you're doing it on your computer, it should open up a Google Chrome tab, and you'll just have to sign in. So, since I'm doing it in Google Colab, I have to do it slightly differently, which is just clicking this link and then sign in using this code. Sweet. Now that I sign in, it should work. Okay, sweet. So now that I've connected to the works, yeah. Is it? No, this is fine. Is it? No, I think it's fine. Yeah, it should connect, and then you can start deploying the model. So this chunk of code registers your model, so you would have to do that when you're doing your assignment as well. So what this does is just basically telling Microsoft Azure where your model file is stored on your computer. So yeah, so since the model is model.json that we saved before up here, and it's just in our directory, we can just put that here and then register it. Oh yeah, so for when you train the Hugging Face model, that one puts a folder of items, of files. You would just put the folder path here instead, for example. Cool, now that you registered the model, okay, you need to create a virtual environment for the model to be run on the cloud. So what that means is basically you need to give it all the Python packages and tell it to install those packages on the cloud so then it can run your model. So for this example, since we only needed NumPy and XGBoost libraries, we we create the environment and add these packages to that environment. And this is what the environment that will be used on the cloud. So yeah, so that's basically what this chunk of code is doing. So in your local machine, depending on what type of packages that you're using to do your model training and processing and stuff, you will probably need to create your own kind of environment and add the required packages onto it. And then this chunk of code basically attaches the environment and tells Azure what entry script file you'll be using. So the entry script file is basically a file that will be run by the model that's being deployed. So when you deploy the model, the model file is being uploaded to the cloud as well. But then the cloud wouldn't be able to know what to do with that model. So you need to give it another file, which is the entry script file, that will kind of interface with the model. So in the tutorial, I've written up an example entry script file. So if we go look in the example under source directory, there should be a file called echoscore.py. So this is the entry script file. So if we have a look at it, so all the file does is load the libraries that you need to use the model, and then it defines two functions. So these are the two functions that you have to have in order for it to work. So you need an init function, which is the initialize function. So what this does is this is run once. So every time the model is deployed, this function is run first. And usually what you do here is load the model. And so you can see here, I created a global variable called model. And then I load in the model.json file to this variable. And then the second function you have to write is the run function. So what the run function does is every time you call the API, the run function is being ran. It'll take in your API call request. And usually what you would do is you do a post request. So that means you're sending data to the API. So let's say you send in some data. Then you need to be able to process that data. And that's what I do here with the JSON.loads. And then I convert it to a NumPy array. And then once you do that, you want to use your model to predict on that data. So you would have to code that up. So depending on how complicated your model is and sort of how you set up how you want to interface with the data, this will be kind of different. But for this example that I'm teaching right now, it's just pretty straightforward. It's just you give it some data, pass into the model will predict, return some output, and you just return the output back. So this is kind of like the back end of the model, kind of like figures out how to interface with your model and then use it. So that's why this file is important. So to get this working, so since I'm doing it on Google Colab, I will need to, again, upload the echoscore file. For you guys, if you're working on your local machine, you can just put it in the same directory as your notebook. Oh, I forgot to mention, yeah, so the way I've set it up is the entry script files inside a folder called source directory. So you would have to make sure that this file is inside this folder. And this folder is in the same directory as your notebook. Okay, sweet. So if you guys have done that, you can just run the code as well. And that should like set up everything. And then the next part, which is kind of the final part, this is the part that starts the deployment. So the model before that you registered, the environment that you set up, the entry script file, all of this is passed into here, and this uploads it and sets everything up on Azure. So assuming that all the stuff you've done before has no errors, this should work fine. Yep, so if you guys have any questions, just put your hand up. This part also can take a while, a couple minutes to deploy. While this is running, it should also show up on your Azure that something is being deployed, and we can see that we got notification. And yep, so it should be deploying, and just wait for it to deploy.
Is there a way to deploy from within the Azure portal itself?
Yeah, you can. Yeah, but I think it's like, so you do it with the kind of like the UI that they have, and it doesn't allow. It's not as like customizable as through code. So with through code, you can do a bit more kind of fine tuning of like configuring and stuff, and also the documentation is not clear on how to do it through this. Yeah. So yeah, oh yeah, forgot to mention. So if you get stuck anywhere, like depending on what you're doing for your assignment, and you get stuck in these errors, Microsoft has a documentation for this. So if you just, or it should be, I put the documentation actually on the README. So if you go to the README, yep, the first link here takes you to the official Microsoft documentation on how to deploy models. And basically what I've done in this example is literally follow these 7 steps. So, and it works. So if you get stuck anywhere, you can always come back to the documentation and kind of read through it and figure it out from there. The documentation is pretty much doing a lot of the same stuff. So you can see the entry script file, it's the same thing. You have an initialization function, and then you have a run function that processes the data and uses your model to make the prediction. Yeah, this process usually takes a while when you first deploy your model. Once you already deployed it and want to redeploy it, it should be much quicker. Since this is taking a bit long, I'll just show you kind of what the final product looks like. So this is kind of the final stage already. Once this completes, what it should look like is you should, so when it finishes, this finishes, and you check back at your endpoints in your Microsoft Azure Machine Learning, you can get the REST endpoint. So that's the API that it creates. Using this, you can access your model. So what you would do is you will make an API call to that endpoint. So I'll just use Postman, which is kind of like a tool you can use to make API calls. So what you would probably do is, it's up to you how you want to use the API. In the next section, when Michael and Sakia teaches the bot framework, that bot framework will need to access an API, and that's where you can, where this API comes in. So as an example, I'll just use Postman to access my API. So This is the API link, a website. You can just paste that in here, and then in the body, you send it the data that you want. And the way I've set it up is that the data is just an array of nested array, I guess. So depending on how you set up your entry script file, over here, depending on how you set this up, how you send the data will also depend. So since I've set it up in this way, when I click send, this should make a request to the thing, and then it should also return an output. So, yeah. Sweet. Do you guys have any questions? I don't think so. It's still going. Yeah, this takes a while. So, yeah, but when this finishes and you check back at your endpoint, you should get a URL here, and you can start using this however you want. In the notebook, I included some code on how you would maybe make a request using Python. So you would just paste your URL here, and this will make the same API call as what I've just done on Postman. So yeah, so you give it the data and it will return a prediction of what it is. So for your assignment, since we're doing a natural language one, you'll probably just put like a string here, so some text, and then the output should be some sort of readability score, and yeah.
Thank you, Jamie. And if you do have any questions about the deployment part, just put your hand up and ask Jamie. Or other than that, like if you did come in late, all the documentation is on the GitHub, so on the deploy model onto Azure. So you can just read it on your own time. Next up, we have Shaman, who will be going through the more advanced machine learning stuff, with hopefully a bit of background into machine learning. So Shaman, over to you. And then next up is Sakya. We'll see if you need. Yes, we do have this one, if you want.
Ravindu, how can I do the presentation mode? I haven't used Windows in ages.
You just do
go to okay. Actually, I'm not going to talk about because this is like the slide said I found from. Have you guys heard of Lex Fridman? He's like doing this podcast, and he's a scientist from MIT. I mean, his stuff. What I like about him is he's pretty easy and like anyone can get it, you know. So today, so my focus would be I'll introduce a bit more background into transformers, and it's like modern day natural language processing or the current trends, and then I'll introduce you to a framework called Hugging Face Transformers, which is kind of pretty useful at the moment in the industry. I mean, I would say it's the most used framework in the industry, and you can see like even in the GitHub it's over 50,000 stars, and it's kind of pretty much active project ongoing. So there are like lot of natural language processing frameworks, right? Like usually it started with ontology based, like you have a word cloud, and then you need to like you can classify a document based on that word cloud, or you can kind of extract entities, something like that. But now all these fields are kind of governed by this pre-trained model called transformer. So it's really important to understand like what is a transformer. So this thing was first introduced by Google in 2018. So the idea is they can train a model with a large amount of text without having specific labels, because label data is hard to find, right? So usually what it does is it kind of uses the connections, combinations between words, because language is kind of interconnected thing. Like we speak, we write according to some kind of a, I would say, a method, right? Like it's been evolved all the time. So first, what it does is you kind of have these words, and then we convert these words into embeddings. These are called like vectors, and then we use something called self-attention that helps these embeddings to understand the connections between words. So the nice thing about this is all these vectors, embeddings, everything get learned with the training data. So this is like the bigger picture, like transformer. Like you have a bunch of words and embeddings, and these things get connected with encoders, and then you can output your result. So so transform is like a big architecture, and then there are several types of such transformers. One transformer is like where most like first one was they call it BERT, and this thing also can kind of get trained without having access to any training data. So they use a very simple analogy to train these models. Let's say in the internet you can scrape a large amount of text, right? It's easy. So this is the sentence that been scraped from a corpus. It's like, let's stick to improvisation in this skit. So what they do is they just randomly mask a word. Now you don't have this word here, right? Then you input that to the model and ask the model to somehow predict that word correctly. So this is, we call this usually, we call this technique as the self-supervised learning, because humans are not giving any feedback actually, because this is like, it's from the input. You just take the input, randomly mask, and you know, like, okay, here the correct word is this word, right? Because it's from there, and you input this to the model, and model needs to predict. Model needs to predict this this word, like, so what they do is like they take millions of text, like large number of text, and then they train these kind of models for days, like which might like take 400K or to 800. Maybe there are like 1 million. 1 million, like GPU cost is getting higher and higher. So what they do is like they take the model and collect bunch of data and just train. So then they found, after that, after they do this model is kind of a language model. That means like that model knows about the language, and it can be used to other downstreaming tasks like sentiment analysis, name entity recognition, or summarization, something like that. So like this. So this is so you will find also like different types of transformers. BERT is just one. There's another one called Roberta. Then there's one called GPT-2, GPT-3. So the idea is like all these models being created or like started with this basic architecture called transformer. And just to like wrap this, transformer is like basically you learn these embeddings, you learn these embeddings, and your loss function is basically you mask a word and you try to predict that word, right? Then what they do is like in the BERT architecture, so you kind of can input these tokens like your words, and that those models can represent the entire sequence, entire sentence sequence from the first token. Here it's like yeah. So like if this is like you need a bit of maths to explain this, but I'll try to explain without maths. So let's say like this. I told you like the entire transform architecture built on the concept called self-attention. Self-attention means like you use this word, you take this word let's, and you check the kind of similarity or connectivity of this word to all other words, right? So that's what the self-attention is, and then they input a special token here. It's like the starting token. We usually call it class token. So if you closely look at this, like this first token, the first token can aggregate the entire information of this sentence, because first token kind of should represent all the information of this sentence, and so they kind of say like you can use like once you train this, you can use this first token as a representation of this entire sentence. Let's say you need to classify this sentence into sentence into negative or positive sentiment, something like that. You just don't need to use all these representations, but you just use the first representation and send it through a classifier, like a linear layer. So yeah, this is like the very high level introduction to transformers, and you can use them in sentence classification, sentence similarity, then tagging, question answering, and so the good thing is you just need to train one model, and that model can be used in several real-world problems. So then we come to this more engineering framework called Hugging Face. So what Hugging Face did was all these transformer models comes from big guns, like these are like billion-dollar companies or organizations, because these models are really big. Like I'm talking about parameters wise 400 million to 88 billion. Like that's so even a checkpoint, even a model size is around 2 gigabytes, and in order to train you need to have 8 GPUs for maybe 4 or 5 weeks. So which is like really expensive. You basically can't train this kind of a model by yourself. I don't think entire University of Auckland or anything has enough GPU capacity to train a model like this. So but what these people did was, they so Google trained their transformer model, and they open sourced the checkpoint. This is our checkpoint. Then Google and CMU, they also open source on the checkpoint XLNet. Then the Facebook did Roberta. Then OpenAI did GPT-2. And the crazy thing is, like, Google uses usually TensorFlow. It's a programming language. And Facebook uses PyTorch. So it's not that centralized, right? Like, if you want to use this model, let's say you are programming in PyTorch, your entire company is like based on Python and PyTorch, and then you need to use BERT. You have to go with the TensorFlow pipeline, which is really hard. So what Hugging Face did was, like, they basically came up with a wrapper that any transfer model can be plugged. So basically, they don't train anything by themselves. But what they do is, whenever there's a new checkpoint comes, they just open source a wrapper. So then like you don't. So you can just use any of these models without actually having access to TensorFlow or PyTorch explicitly, and yeah, so that's like, think of this as something like Android, right? So this is basically Android for transformers or NLP. Like, you kind of can use it. So yeah, so this is like how big these models are. Like, so Megatron is from NVIDIA. So you can see, like, it 8.3 billion parameter model, and it's like you need 512 GPUs to train. Like, that's crazy. Like, it's clearly $1 million cost, and yeah. So Excel. So same. This is like, I'm just giving you the idea. Like, if you know how transformer works, you can kind of understand all these networks. You can see, like, they are almost same. Like, some models just try to predict the mass token. Just remove the word cat and ask the model to predict the cat. And what some models does is just try to predict the last word, next word, because languages are usually going from left to right. So I like to play the next football, cricket, or whatever, right? Like, so next word. So then there are like models like which are kind of distilled. You have bigger models, and the community kind of distill them into smaller models in order to use it in industry and kind of run fast applications. So this is the amazing thing of transformers like GPT-2. They are really good with generating text, because they've been trained on, you take a large corpus, and they've been trained on predicting the next word. So these models like GPT-2, they can generate nice text like poems. So you can see, like, you input this into the transformer, the meaning of life is. Then the transformer generate not what I think it is, like something like that, a bit more dramatic. Then the limits of deep learning are still the progress of being figured out. And yeah, so this is the author experiments. Best quality is that he's smart, but yeah. Yeah, so still, even like my PhD research, I'm interested in this. So still, these language models are not that much good at reasoning. You guys know, like, what is reasoning, right? Like, if you have a bunch of text, let's say like you have you have some incident. I went to this place first, and then I went to that place because the party wasn't good at place A, something like that. Then if you ask like why I went to place B instead of place A, so it's still transformers kind of can't, these language models. So another thing is like math, although like for humans this is really easy, like but transformers kind of still struggling, like so still they are not like 100%, so they are much lagging behind reasoning for sure. Yeah, so like so the idea, like what Friedman says is like, and so these transformers basically kind of improves the natural language processing, and they improves the understanding of text. But yeah, so still there are things to improve. Yeah, there are like, but I just don't want to go into this. I want to go to some coding. But do you guys want me to like give some introduction into math of the transformer, or you guys good with doing a coding thing? Because I can give some introduction into the math behind it if you guys want.
Put your hands up if you want it.
Yeah. Okay, so yeah. Maybe at least self-attention a little bit. Yeah, okay. I'll kind of, think like, yeah, because yeah, so I mean, I'll quickly go it. So first, transformers, as I mentioned, it came for sequential data. So most of real-world scenarios are sequential data, right? Like text or speech, then stock market predictions. So you need to like capture a long-term sequence, and you need to try to predict like your model should kind of learn long-term things and then try to predict. So this was the architecture. This is pretty mathematical thing and solid thing, which came even before neural networks, like long short-term memory or recurrent neural network. So this was there until 2018. So the idea was you have an input, and then you have some gates in. So this is like a one cell, right? This is like a cell, which is like an intelligent cell. So inside this cell, there are like gates, which can, we have like 3 gates: forget gate, continue gate, and then the other thing is input gate. So these gates kind of can control what information will it learn. So in this cell, like let's say, so ideal, like theoretically, this gate should learn what to forget and what to keep and continue. And after that, like let's say this, like you need to predict the stock price. So you just put, okay, this stock for the price of the day today, like 10 days, like you just put the prices for those 10 days, and 11 days it should be able to predict. So this was there until recently, and then so we basically we call them, like as I mentioned, like sequence to sequence models. They can model a sequence. So what we have is like, how are you? So you put like so just imagine this is like a chatbot. So most of chatbots before 2018 was built with LSTM, long short-term memory, or like some if-else. So it's this like you can input 3 words, how are you, and then you can learn a compound vector which kind of encapsulate all this information, and then you have a decoder which uses the encapsulated information and try to generate the answer. So this is like the beginning. This was the like people already found, okay, if you have this kind of models and if you have vector representations, you can possibly learn long-term dependencies and also can predict or can generate the future. Then you need to, like if you want, you can read it. So what happened was there was a problem they found. We need to something called vanishing gradients. So what happened was when they tried to work around longer sequences, they could not train these models because we call it like back propagation through time. So basically, it's like more like from if you try to model your training mechanism from this level, let's say this is like 10 words. 4 words here, and you need to you are trying to predict the 5th word, and if the 5th word is correct, it's good. You give a positive feedback to all these cells. If it's wrong, you give a negative feedback. But what happened was when the sequence are getting bigger and bigger, it's not easy. It's not easy, and the gradients started to vanish, and it's kind of it became mathematically impossible to train this stuff. And the other thing is these things are not parallelizable. Like in order to calculate this, you need to make sure this time step is done. So like that. So it took a lot of time to train and very hard to interpret this stuff because it's pretty much model-based mathematics there. Then like the key concept was like, actually, if you start NLP now, or if you are going to apply this in industry, this is all you need. Like at the moment, nobody actually knows what is LSTM, people who started after 2018, because then they found, oh, all we need is like most of real world scenarios. When we are talking, when we are looking at something, our brain, what it does is it just attend, like it just uses a lot of attention, and that is enough to learn any hard thing. Yeah, that was the idea. So I'm now this is like the attention part. So the attention part is like you can say like if you want to this like think of this as a translation problem, right? You need to translate this phrase into English. I don't know. I think this is French, right? So then is it German? Okay, sorry. But you are from Russia, right? Yeah. Okay. So yeah. So this is the German phrase, and this is so you need to generate the English phrase for it. So attention is more like, is there a way we can combine? Is there a way we can combine all of this information into one? Because sometimes so word by word or the semantic meaning, something like that, then you use this attention to then try to generate the output, like the greenhouse, something like that. Yeah, this is like soft. So yeah, but in mathematical wise, what happens in the attention is, if you just imagine you have vector for the word the, and so then you transform this vector, but it's more like a transformation to the vector the, by adding all the useful information of the sequence. Like this weather, just take the word weather. So how much weather, the vector weather is connected to the other words like is, the, nice, today. Let's say like, as humans, we know weather and today is kind of very much connected, right? Because it's like we use these phrases. And then the weather, of course, it is like the weather. Then weather and nice. These words usually lies in similar distributions. So self-attention and the math behind transformers is just this, like this is simple vector multiplication. Yeah, it seems a bit, different, but what it does is it just like get the cosine similarity. You just initialize a vector, as I mentioned, they randomly initialize all these vectors. Like for example, what they do is English language usually have 50,000 words. It's not like words, but subwords also, like environment. ENT is a word, environment is another word, like ENT, is, boy. Those things are like, we call them tokens. So usually at the moment, English language consists of 50,000 such tokens. So what they do is they initialize 50,000 vectors like this, 0.6, 0.2, 0.8. Like this, just imagine this is like randomly initialized vector. So all you need to do is you need to modify these vectors in a way they represent the similarities in the language. So ideally, you can see like what it shows is when you kind of dot product the vector the with all these vector, obviously this value will be the higher because it's the same. Then it's more like this. What is the closest vector to this vector? It's more like ideally the weather vector should be closest to today because it's a day and we talk it, and we always represent in that way. So yeah, so maths behind this is like basically you trying to highlight the similarity or try to highlight the representations or semantic meaning of text. Yeah. So like the only difference in BERT or transformers is their attention is bidirectional. Like if you take this word, what happens is the representation of this vector it being transformed to here. Like that means you have bunch of this kind of operations happening. So end of the day, when you take this vector, it represent the connectivity of at to hello and GFC. Basically, let's say in a perfect scenario, maybe at should be much more closer to hello because hello at something like that. Yeah. So this is like the inner workings of transformer. So you can see like it just like you have a lot of linear transformations, just like vector multiplications. So yeah, so like you can check this kind of stuff later, but try to understand. So idea is like you represent any word with a value key and query. So so let's say we take a word we take a word boy, right? The word boy. So for the boy, there's a way. So that being represented by a compound vector. One part is the value. Value means like actually what it consists of. Like maybe it might, that this part might contain the gender information or the grammatical, like grammar behind when you are using the word boy, or like then we call this as the key. Key is more of it's more like an address, like where are you in a sentence, where this boy word might be most suitable. Query is more like when you need to kind of compare the word boy to another word, like a girl, let's say girl or something. So this vector kind of act. So this is like still you have a compound vector, but it's been kind of divided into different tasks. Yeah, this is again the same self-attention, and so the idea is so in the self-attention you always compare the value vector of one word with the query vector of other query inquiring, like, yeah. So I mean I can share this presentation, but all I want to highlight is it's basically built on the cosine similarity and the softmax, but yeah. So yeah, I mean, yeah, that's too much. Yeah, so I'll then quickly so I mean, still you can use this transformer without knowing any mathematics, but I suggest it might be nice for you to understand the maths behind it. So let's introduce to this thing. So this is the Hugging Face. So as I mentioned, so it is basically the open source thing where you can use these pre-trained models, and they have for your different tasks, and also now they have an API where if you're working in a company and you can basically pay for them, then they will host their models in their backend and do the data infrastructure. And also there are like interactive things, like for example here we need to go to question answering thing. So you can see, like, so you have a bunch of text here. It's about Amazon rainforest, whatever. Then you ask a question: how many square kilometers of rainforest is covered in the basin? And this part is basically the model. Like I told that there are like several transformer models, and this part is basically like what's the model being used. So where's the so yeah, so you can compute and it can give you an answer, so you can actually take this. Let's copy this text. I'm just showing like how easy this is to use. What is this should be pretty easy actually. Yeah, so what is transformers is about this library name also transformers, right? So it says it provides thousands of pre-trained models. It kind of can relate to this context and answer it. And there are like so many tasks you can see, like these APIs. You can just, let's say, if you go to text generation, this is like once upon a time I dance a lot. So yeah, sometimes I know. Yeah, it's I don't know, like some, yeah. So these, so and then if you want to do yeah, we should delete it. So I can't delete it. So then I'll kind of so yeah, just like it can generate text. And if you want to do much more sophisticated development and stuff, you can download this checkpoint. It's like the model checkpoint. It's 1.3 gig. So yeah, so that's one thing they are giving, like easy access to. So now, like if for example, even for research things, like, so I wanted to have a model that can summarize conversations recently. So actually, so now, yeah, so yeah. Yeah, so here, like, this is a model that been trained on summarizing conversation. So you need to, like, so they will give you, so if you click here, they will give you the pipeline, like how to use it, like how to load them, and I'll go through this just after this. But again, like here you have a conversation, Jeff, Philip, and some conversation, and this model, this is the model name. This model being trained to summarize conversations. So if you put compute, it says Jeff wants to train a transform model on Amazon SageMaker. He can something like that. So that's one thing. So I also haven't touched this part actually, because at the moment I'm not working. But seems like try this out. Read this thing. And yeah, so that's models. This is another good thing. So let's say you need to do a project, you need to, because usually even in research or industry, you need to start, when you need to start, you need to make sure to utilize all the available data. So these people also gives easy access to almost all the text-based data sets. So again, like if your thing is like question answering, these are the data sets they have. So when you click it, you can easily like load them. I'll show you how to load these data sets. And also, like, they have this nice they are developing a lot of UI. So you can see, like, so now, like, you actually don't need to work, like spend your time on exploring a lot of CSVs or whatever. They just show it like, oh, this is the like overview of the data set. Will it work for you? And they will give you a good description. Yeah, that's so. Yeah, now so now yeah, now before that I'll give we have a documentation also, right? They don't have a link to documentation. It's weird, right? Anyway, it's fine. Yeah. So, yeah. So this is their documentation. Then you can remember I told you about different models, and let's say we need to have a bird, right? So if you type bird, it kind of give you an overview of the. So you have the paper. So this is like, this is really good. Like anyone can start to work hands-on while learning the theory. So if you just go there, there's the paper, and you can kind of read it. Even that's how like everyone does. Usually people who are working in NLP. So they have this. So they kind of say how many layers this model consists of. So pretty rich documentation, and also like how to easily load these models. Yeah, and another useful thing here is so at the moment they use like these 3 libraries are the most important in real world engineering project. This is tokenization library. Like it consists of bunch of tokenizers. That means like, as I told you just can't use English words. You need to like convert them into IDs because so this library gives that ability to tokenize any language, most of languages. And the dataset library also really important, because so this can make this entire training process really fast, because usually when you are trying to train these bigger models, you need to make sure your model reads the data from the disk very like in a good speed. Otherwise it takes a lot of time and it might add a huge bottleneck. So this dataset library is pretty good for that, and the transformer is the models. So yeah, so what I'll do is today I'll show like how to train a sentiment classification model within 4 or 5 lines. So the other thing is these people have started a course. You can so it's called so it's free, and so they please like do if you want to use this library, you can just it's really new. It's been like 2 months, and even they talk about like how what can they do, and also like without going much into maths, more like from the engineering point of view. And also they have like they have some hands-on experience things. Yeah, let's do a collapsing quickly. Transformers collab. Yeah, so we need to put GPU first. So so it's there in so you also can try this later, but I think so I'll show you how easy. So pip install datasets. So first you need to, first you need to install the dependencies. Like dependencies are that so it's just easy pip install transformers library and the data sets. So what they will do is they show like how to train a sentiment classification on a data set called IMDb. IMDb is consists of movie reviews, positive or negative. So first you need to first you need to install transformers, then the data set. So look how easy it is because they are not even using. So you don't have to install. So I did not install PyTorch or TensorFlow. Just like I have a usual pip environment, and I just simply install these two libraries. That's it. So that's the good thing about using frameworks and getting used to frameworks, especially in AI. So yeah. So then the nice thing. So they have a lot of I told you they have a lot of data sets, right? So they have they also wrap all these data sets around around a library. So you can kind of go to their documentation if you want. So in the documentation it says like if you go to load a data set, and so yeah, so you can basically the cell. Oh, sorry, it's a function. So like this is the amount of data sets they have, right? So yeah, there are kind of a lot. So let's say so you can access them with the name. Yeah, now it's like I can yeah. So then let's say I just select this data set, so I can I don't even know. So it's this one. So then I can kind of call it my data set. So I can put my data set. So load data set. So yeah, you can see like it even so it even like downloads the data for you and saved in your cache. And yeah, sometimes so some data sets you need to give another like some more keywords. Then even for that they give suggestions. So now the library is saying, okay, your selected data set is this, and yeah, I don't want to keep download. It's like it's 681 megabytes, right? So now let's delete this cell, clean this up. So now like this is the IMDb dataset, right? So it consists of 50,000 so you can see like what they do is raw datasets, they use the load dataset and the name. So if you want to know which dataset you want to go, just go to this documentation. So here you can kind of select, right? So for me, like now you can type sentiments, right? Sorry. So if you type sentiment, there are like several sentiment related data sets. And then if you want summarization, so like then news data, CNN, Daily Mail. So all you need to do is like you click this and copy this part and go to your code and just paste it here. So now the good thing is like usually in real world scenario, these data sets you use might be 10-20 gigabytes, and you basically can't load it into the RAM, right? But what this dataset library does is it has a C++ backend, so it does not load anything into the RAM. It uses arrow files. So basically, you can load 190 gigabytes, because I tried that 190 GB data file by only using 9 megabytes of RAM. So which is like pretty useful in real world applications. So then after that, the other thing is this is more like pandas. Now you can explore this data set. So just like usual Python codes, raw data sets, you just like, you can see like it says it has splits, train, test, and unsupervised. That means which is not labeled. So this is like a dictionary. Then if you want to if you want to know how many examples, so it says number of rows, 25,000, 25,000, and 50,000, right? Then let's say if you want, now you need to check what's the first element of this data set, just to like get used to it. So simply you just need to do is like type the split. It's like usual Python structures, train and yes, this should work. Yeah, so it's a label one, that means a positive sentiment, and it has the text like text about it, and I'll say do the. So if you want, you can actually easily do a for loop, like, and traverse through the data set. So element in data set train. So here you can actually, I'm not going to run it because it sometimes crashes the call up when you run when you print a lot of stuff. Oh, sorry. So yeah, so this is like this. You can traverse through it, and then the other part is, so now these are data sets that they provide. That means they have a script to load it. But now let's say you have a huge CSV data set. So usually what you do is use pandas or Dask, but in deep learning you can't use pandas or Dask, because what happens is it will so basically then you can't use them in the training loop, because of the RAM consumption and the number of workers. But let's say if you have your own CSV file, you can still do it. That's how like we usually load data. So if you go to actually, I mean, this documentation is the best I've ever seen in machine learning in my few years of experience. So you can now, let's say you have a CSV file, right? Just imagine you have a CSV file with two columns. So basically, you can use this exact load dataset, but you need to give these keywords, and then you need to show where is your data file. Then so then you can you might now not understand why isn't this same as the pandas. The only difference is, just imagine you have 20 gigabytes of a CSV file. You basically can't load it with pandas, right, and feed it into a neural network during training. But now the good thing is you just can use it and you can play around with it. Yeah. So that's datasets. And then this is the thing that I told you about the tokenizers, right? So tokenizers, so as I mentioned, in NLP you have a text, and then in order to process it or use it with a deep neural network, you need to convert it to tokens. So basically you need to have a bunch of tokens for this text, and we call that process tokenization. So it's basically mapping a word into numbers. Then those numbers will map into an embedding, something like that. So so this model, so there are like several tokenizers, like standard tokenizers, where the research and the industry community are using. So one thing is called bird-based uncased case. That means like the thing that used in bird. So this library also gives you the access to that. So I'll show you like what is actually happening, how this real input being processed before sending into the deep neural network. So here, let's take a sentence, right? So sentence is and text print it's really hard to code with this keyboard. So okay, so now this is the sentence, right? Then I need to tokenize that sentence before sending it to the neural network, right? So that I'll print the input. Okay. Yeah. So this is a sentence. And after the tokenization means that sentence being divided into some tokens, numbers, but don't mixed up these numbers with the embedding. These are not the embeddings. So what happens is now we have an embedding set. Like for 101, there's a embedding. It's more like a code book. For 101, we have an embedding. For 139, we have an embedding. So these are like mini words or part of words. So commonly used words, it's been like tokenized. And similarly, you can you can tokenize your entire data set. So basically, before using any NLP model, you need to tokenize your text. So similarly, so you can see like this, just like still we are working on the dataset library. So this is like entirely optimized for text, and it works really fast. Yeah. Now what it does is it kind of tokenize entire data set we have, and making it ready to use with the transformer. I really can yeah, just like I just want to see like how much RAM it consumes. Yeah. Yeah. You can. Okay. Yeah. Nice. So then we kind of split data sets. You can see like splitting data set also pretty much the standard in any neural network thing. And yeah. So this is like usually in any project you kind of play around this. So the difference when you are using an image or text is, especially when you are using images in deep learning, you can just convert the image into numbers and feed it to a convolution neural network or whatever. But in text, you need to do some pre-processing. Like you need to tokenize it first, and then only you can move forward. So yeah, then so then we are coming to the transformers, the real transformers library. So as I mentioned, like it also gives you now this is a classification task, right? You need to classify the like your the review into positive or negative sentiment. And there are things like auto model for sequence classification. That means like you really you actually don't know what model you should use, but you need to, it's a classification task. So again, like, so if you want to know like how to do it, just Google, and yeah, they have a documentation for auto classes. So this consists of what classification. Yeah, so this is the class, and then what they do is, like you can see here, they import a model. So for the model, again, like now let's say I need to get a Roberta. I'll show like. So there are like different models like Roberta base. Yeah. So now they are you are just loading a transformer model. That's a BERT. Like you are loading a BERT transform model, and yeah. So yeah, and it kind of you can actually check what's that model is. Just so it kind of also print out the number of layers and layer names and stuff. So then let's say you need to have a different model, right? So something like this. So Roberta is another model. So you just need to change this, and it will download that. So it has 501 megabytes. So the idea is like always use these wrappers and classifiers like in this thing for your task. So similarly, like for so similarly for like yeah, all these models kind of says like how to use and where to use, and so then like now we have a model, and so then yeah, this is also really important. So when you so usually you can easily train a small model, but training a large model requires a lot of engineering hacks, like logging of the training time, training matrices, and feeding the data into the model, and kind of controlling how many training steps should be there, and then what's the optimizer you should use, is Adograd, Adam, something like that, and then how to schedule your learning rate. So because these models are kind of million parameter things, so you need to follow certain empirical findings to fine tune them properly. So what these kind of frameworks do is like they also gives you the ability to like use another like kind of a hook function, what do you call, like it's like a function that it's more like, okay, you only think of the task, because training, if you train most of these models, although they are for different tasks, the training mechanism is same. Engineering wise, it's kind of, you need to follow the same set of steps. And yeah, so this library kind of helps you that also. So you can see like these train arguments, you can actually print what it says. So this is like, you can see, so this is a dict. You basically can change this dict values and everything. So number of GPUs and what's the beta, alpha, whatever, like because you need to label smooth, you need to use F16 in training. These are like, you will learn once you start to use this stuff, because how batch size and everything. So so you don't have to write your arguments separately. You just can access this stuff and just change it. And then yeah, then like that's like interface. That was the interface for the training arguments. Then you basically initialize a trainer. So so now what this does is, when this is more like a function, you need to give a model. Okay, this is my model, and so model also initialize the task. So in our model we use a classifier, right? Classification task, and the model kind of so we pass these argument. Here's the model. My task is classification task. Here are my like training arguments, like how many GPUs, what's the batch size, should I use F32, should I use learning rate like decaying, or what kind of add a factor of like those, the hyperparameters. Then also I pass the training data set. Now see, like if it's not research, this is ideal. You can make your data set separately, make your model. You can select whatever the model you need to have. Then then you can also pass the evaluate data set. You just need to you just pass everything. So what this thing does is it just like start the training loop for you. So it will feed data and keep training. So then like trainer.train means it uses the training data set and it will train. So you can see it gives, so especially, I mean, not much in research, but in industry, your boss will ask about these logins. So, because I have worked in industry before, so the main thing in machine learning in industry is like login. You need to show, like, you need to check how the training is happening, whether the loss is going down, how many gradient accumulation steps are there. So you don't need to print anything. Those logins and everything will be taken care by Hugging Face. So now it's getting trained. So what it does is we just put, I think, 3 epochs. Epoch means like, 1 epoch means the model sees the entire data set. 2 epochs means model sees the entire data set 2 times, something like that. And we just use 1,000 examples for training, and we load 8 examples per GPU, and it kind of now getting trained, right? So it's not that fast. Yeah, so usually, yeah, till that I'll kind of finally show the trainer. Class. Yeah. So if you want to know like what is this trainer, or so this is documentation of the trainer, and so you can see like it's been optimized, and so inside I'm going to tell a bit about this also. So so now in this trainer part, it says these are like so to inject custom behaviors, you can subclass them and override the following methods. So so let's say now you are not doing any modification, right? You are not doing any modification. You just use a BERT and classify the sentiments. Let's say now next you don't need to classify, but what you need to do is you need to regress. You need to predict a number, real number, something like that. So unlike previous days where you need to go inside the code and change these lines, like with this method, you just can use some hook function. That's what they say. So basically, let's say you need to change your data set, like giving data set loading. So you can easily you guys know about hook functions, right? It'll be like, is it in software engineering? Should be, right?
Functions?
No?
Functions.
Yeah. So yeah, a hook function is like you have a pipeline. Let's say you have a pipeline. I don't know much because my major is electrical and electronic. So hook function is where you are not breaking that pipeline. You can write an independent function that changes the behavior in that pipeline. So the code is clean, so reproducible. So it's basically you are not, so idea is, I mean, now it's maybe a kind of a new concept also because it is getting very popular now. So idea is, especially in these open source things, you should not change the source. If you want to do a modification, it should be minimal and it should be easily chunked, you know, like, so this like, it's more like you basically override a function in a pipeline. So let's say like so if you want to change something, okay, so at the moment, let's say you need to augment the text, you need to like add some noise into the IMDb text. At the moment, it doesn't do it. It just like get all the data and feed it to the neural network. Yeah, now it's been trained. So then, yeah, you can actually share your model also, like, because if you want, you can share like here. So for example, let's say, so this is the guy, the person's name, and this is his model. So yeah, his research interest, and yeah, this is like nice way to, you know, like get community attention, and so now this train output, it gives like the global number of steps 375, and the training loss is 0.6. Obviously, this might go less if we train more, and then I think this is we need to we can also get there should be, we can also like put here, like I did not here the do eval is false, but if I put true this thing to true, it will also show you some kind of validation accuracy. But I just want to now like next is to you need to check a model, and for that you need to check like how it works. So usually you train for a few epochs and then check it with another dataset, validation dataset. One thing is, usually in machine learning we always say like you need to have a validation dataset while training, but in this, especially when you are in transformer, since they are like large models, usually they say like, okay, fine-tune the model on your downstreaming task for 2 epochs. So basically you don't need a validation thing, but I personally use, but it's like, because these models been already trained on large amount of data, you are just trained on sentiment analysis. So you just train for like this. So they say for sentiment analyzing task, just train the network for 3 epochs. That's why you don't have a validation data set. And so here they also consist of, they also have different matrices like accuracy, exact match. You can, because so this is really well documented. You can, so now we need to evaluate, right? We again like, so we have now like we have 1,000 examples. So we use the previous model which been already trained, and now we are evaluating it. What?
Where do you get that link?
Yeah, I'll share. Yeah, so actually the course is free. Yeah, so so if you go to transformers.core.notebook, so yeah, I mean we can put the link in the GitHub, but just type transformers notebooks, and then you have this bunch of tasks, so you can actually start working, like start hands-on work, like so here I open this how to train, how to use the trainer to fine-tune a pre-trained model. So just click it. Yeah, they have a bunch of tutorials. I mean, yeah, this is, and you can do their course also. Where's the course? And follow their Twitter always. They are pretty active on Twitter. Yeah, now we are done with yeah. Yeah, I don't know. They say in the course it should get into 87.5, but maybe like we train with very little amount of this 1,000 examples out of 25,000. So the accuracy at the moment is 51% evaluation accuracy. It's pretty much good, like same as training loss, and validation loss is same, which means there's not much of overfitting. And if you have if you want to test also, you can test it. So yeah, that's like basically I wanted to give you guys an introduction to this library and how useful it is. I'll kind of give me like I'll finish explaining this trainer thing, because you guys might be, because in your tutorial you will be trying to rather than classifying, you will be trying to predict a score, right? So usually transformers at the moment being used mostly for either for generation, like generating language for poetry, summaries, paraphrasing, questions and answers, and then for classification. But then you might be wondering like whether there's a regression, like because we just used, if you guys remember, because they give the access, like this auto model for sequence classification. That means like they have a wrapper, they have a class you can easily use, but for regression tasks they don't have, because it's not that common, like it's not that, but you can always use. That's where you need to play around with these hook functions, which is the most important thing. Like usually you might not need to mess up with the optimization, also schedulers. Here, let's say now in a regression, the difference is it's not a binary cross entropy loss, it's more like mean squared error or something. Then you need to update this function, and then like the training step also might be important. So just like one example, so this is a nice example. So all you need to do is like so you have a so what you need to do is you need to like import the trainer. This is what a hook function is. So basically you need to like change the loss function, right? So what they do is like you need to create a class. So this is more like multi-label trainer, but you subclass it with the main trainer class, and then what happens is now like so they are in their trainer also they have this function compute loss. So you basically what you do is you kind of override that function here. So yeah, so what happens is so rather let's say like I'm just so just a quick thing if I show you. It's like really easy. I don't know how we, so now then how I, so let's say in this is like a perfect hook function example. You create your own class, subclass with the trainer, and my new it's really bad. My new trainer is this. So basically I can just comment out this and so just like giving you an example how, so sorry. So I see it does not pop an error, you know, like all, because it's basically the good thing is like, okay, because this class doesn't have any initialization, right? Usually it should give you an error. So what I do is I just use my new trainer, right? And then I use, because I only override this compute loss thing, right? All other things are same. So now this thing, so we can actually just type, so I'm just overriding the parameter trainer equals my, actually I'm in love with this, and there's another one called PyTorch Lightning, you guys should try it. So this is like, yeah, because our input doesn't consist of a label here. That's the thing. Like, but yeah, because you need to have a you need to match the target size with the input size, and here like yeah, but I hope you get the idea. Like we have to maybe change this stuff according to that, because at the moment they should. I'm just testing something. Just quick fix. Yes, I mean, yeah, but it's like it's according to because I just want to show like the algorithm goes to this function. Like as one last. In Colab, can print? Can't, right? Show me. So I just want to. Sorry? Yeah. Anyway, like that's the idea, and check the this gives you all the arguments, what you need to do, and yeah, also in just as the last thing, so let's say you need to do a bit more sophisticated stuff with the transformer. This is the Git, and then you can go to examples. So there are like several so let's say if it's summarization, they will give you they basically have the script wise if you want to go. Like I mean, if it's a long-term project, I suggest you to use this, because that's you really need to know what is happening. You should not work on Colab if it's a long-term project, but as an initial thing, it's good. Then there are like you can actually if you work hard, you can contribute to this research project repository, and me and Ravindu, we actually added this extension, this new module called rag end-to-end to the transformers library. I mean, it's good. Like the good thing is like it's not rocket science. Like you might find these different blocks. You might able to like put them here and there. If you think, oh, it's kind of solved a problem they have, you can always pull request them. They will accept you. So they will also like this. So everything is from open source contributors. So yeah, and try this transformers thing. Like get the basics. I know it might be a bit messy because it's really hard to cover everything from the beginning, and even for me still sometimes it's hard to like you tend to forget the concepts of transformers because it's kind of pretty much like you have to stick to that. But yeah, try to start something, and you have. I think there are so many resources, and you can always ask if you need any help on that. Yeah, I see.
Cool, yes. Thanks, Shaman. Now we'll take a break for lunch. And then after lunch, we'll be looking at the Microsoft bot framework stuff with Sakira and Michael, maybe. So we'll be 1 hour, 15 minutes. So maybe be back by 1:45, 1:50.
Huh? I'm just
start, right?
I'm sorry.
Yeah.
Okay. Okay. So we're a bit late, but we're just gonna get into it. So I assume you guys have Bot Framework Composer and Bot Framework Emulator installed. Hopefully, because that's documented. Okay. All right. So the first thing that we will do is, okay, I'm gonna show you first that what is expected to be done by the end of this tutorial. This is only like for tutorial purpose. For your assignments, you guys will be expected to modify it based on the requirement. So what the Bot Framework Emulator essentially do is help you guys build like a chatbot. Usually can be put into maybe Microsoft Teams, maybe Messenger, maybe Telegram, maybe even like your own web app. So this chatbot will be able to automate different stuff. So this is like a Microsoft built one. One main feature of the bot itself is also something called LIS, which is a language understanding module that allows user to input like different commands and for the bot to like understand those commands. So for example, in this one, I will ask, so I created a bot. So like, let's say I ask help, right? So, let's restart that. Do I have internet on? Okay. Yep, so for example, this help message. So the bot will recognize that we're asking for help, and it will be able to like tell you what the bot actually do. So for this one, the bot actually say, oh, for now I can only help you with fetching anime quotes. So I can go ahead and cancel that. So this is also a different feature as well. So the bot can actually ask you a question, and it will expect a particular input. So in this question, the bot only expects you to say yes or no. So you can say yes, and it will do something depending on that. So that's the dialog feature. But there's also like an interrupt, which basically at any given point in the dialog, you can say like a specific command that will break out of that dialog. So for now, let's say I want to ask for fetch a quote from Naruto. Yep. So the bot is successfully able to recognize the command, which is fetch a quote, and then an entity, which is Naruto. So it will be able to like do different things based on that. And in this particular case, it's calling an API to get a quote. Cool. So now that you guys see where we're going with this, we will actually start building the bot. Can I confirm like if you guys have bot framework emulator installed on Composer, or you guys don't have it? Those who have it can like raise your hand. One person. Nice, that's fine. For you guys who doesn't have it, you guys have problems installing it? It should be documented here in the prerequisite. It's also documented, I believe, in the actual, yeah. So yeah, if you go to this link, you guys can install it. Once you guys have it, so I'm gonna like build a new bot from scratch. Okay. So we're gonna make a core bot with language. This one will allow you to have both the bot itself, and it already comes with the language understanding. So we're just gonna name it as a tutorial bot, and we're gonna try to create a new folder. No, that's not what I want. All right, whatever. Yeah, so you do that. So just a little bit on let's go ahead and see while it's downloading. If you guys have Azure as well, make sure you guys have the credits for it. Like it doesn't require you to have to spend any money, but there is like some configuration that I will actually go through as well, so that we make sure that we use the free one. Does anyone have problems like installing the framework and the emulator? No? You guys all good? You guys have it installed now or not? Can I get any response? Cool. So after you have that created, you want to click this one. So you want to set up your language understanding resources. So you can go ahead and choose the create and configure new Azure services. This will ask you to log in to your directory. So for my one, I'm just going to use my personal email. And you want to choose you want to choose your directory, and you want to choose your subscription. If you're using Azure for students, you will have that. I have also my other one, but yeah. So you choose that, and then you click next. So you want to also create an Azure resource group. You can create a new one, or if you have an existing one, you can do that. But I think it's good to have a new one, so you can put all your resources regarding this bot into the same resource group. This will allow you to delete the whole thing together if you want to stop them and just manage them in a group. You're able to move them later on as well, but I think it's just way easier if you put them all in the same resource group. Yep. So the region, just choose the closest one on where we are right now, which is Australia East. Let's check whether we're doing the right thing. Yep. Sounds like we're doing something correct. Now we're just going to be done. So this should mean that this is done locally, but we want to make sure that whenever we push or publish the bot inside, we're also publishing it to the correct resources in the internet. So we're going to go through deploying it. So this also means that we also want to create different profiles. So if you guys already did your Azure fundamentals, if you guys are taking the I1, you guys will remember that there's two different management profile for cognitive service. There will be an authoring tool, and there will be a prediction tool. So the authoring one, the authoring one is the one where you actually create and test your services, but the prediction one is the one where you want to put into like production. The reason why you want to separate this is like financially, your company might not really need that much power for the authoring tool, because like only like the developers there will actually work on it. But like when you are putting into production where potentially more people will use it, you want to split that. So let's go ahead and see configure your bot. So that's done. Connections. So yeah, we want to go set up the publishing profile, and we want to add a new one. So you can either create new resources, but you can also actually import existing resources. So for example, if you already have these resources on Azure and you deployed them through Azure, you can actually use this option to basically just link your bot to it. But right now we're going to create new resources. I will also show you guys later how to import existing resources. Let's get the folder directory, Azure for Students again. So this is where the resource group becomes handy, because you see this is the one that we created just now. To choose Australia East just to make it easier. Right, this is where it becomes quite important to look at, because a lot of these are not free and you want to change them later. So first of all, there's this Azure Cosmos DB, we don't need them. Application Insights, you don't really need them here. Like basically almost all of this you don't need. The only one you want, because the understanding authoring account, you actually created them when you create the bot, so you also don't want it. You also don't want Q&A maker. So other than the necessary one here, this is actually the only one you want to make. I hope, let's see if I'm correct. This is my own notes. Make sure you as all options. Okay, so we already made one of them, and we'll just create the rest manually if we need them. All right. So yeah, actually I'm gonna teach you guys to create the prediction account manually anyway. So the only one that it will create is an application registration, Azure hosting, and bot channels registration. So this allows you essentially to connect. The channels registration allows you to connect to different channel, so you can connect it to Teams, you can connect it to Telegram, you can connect it to Messenger. So this basically helps you to do that. The hosting is the one that actually hosts your chatbot in the web, and the Microsoft Application Registration is just registration IDs. So let's go next. Just making sure it's correct, and okay. Right, so now we'll go to Azure and just check whether or not those resources are created. So if we go to resource groups, make sure you also select the Azure for Students one. Sometimes it just doesn't show up if you don't. So yeah, it's there. And should be deploying some stuff. So as you can see, the authoring tool is actually already there. Where we're gonna look for deployments of the other ones pretty soon. Yep. So as you can see, the publishing one is created and the altering one is also created. Okay. Let's see if we have all of them. Finger cross. Yep. So as you can see, this is all the ones we want to create. So this is a publishing resource. Now, the only thing we want to create is the prediction resource. So how we're going to do that is we can just go create, and then we'll search, I think it's language understanding. Yep. Go ahead and click create. So pay attention here because there's an option to create both altering and prediction, but because we already created an altering one from both framework, we can just choose the prediction one. Another important one is you want the free one. Don't make a mistake of making standard one and then you get charged a lot. What? Is it Australia? Okay, here we go. Cool, Azure for students, the resource code is that one, Australia East, and free. All right. Let's click create. Waiting for that, let's look at our documentation. Select only the prediction resource, blah, blah, blah. Cool. Right, it succeeded. So now that we have both our prediction outer internal, we must assign them back to our bot composer profile. So this is where I'm going to teach you to pretty sure that one. Publisher bots. Okay. So if you go here, you can go edit. So once you got that, you remember when just now we create new resources. Now instead of that, we want to import existing resources. So yeah. So in this JSON looking file, we're basically gonna put our list ID from our Azure resource, basically the endpoint and also the app ID. So we'll copy that, put it here. So this will be the same name as your prediction resource. So for me, it will be MSA tutorial bot prediction. Hopefully that's correct. And yep. So in the list settings, what you want to go to is you want to go to your prediction resource, and you want to get the endpoints and the ID. The key and the endpoint. So endpoint key. So the one with just endpoint key is the prediction endpoint. The one with outering key is the outering endpoint. That here, and then. Because we have Australia East, that means we just put Australia East. Okay, cool. I'll just walk around and see. Okay, so it looks like a lot of you guys, or if not all of you guys, are having problems creating these resources. So these 5 resources that you need to have the bot up and running. Because like this was supposed to be created using from within the app. So let's try creating it from outside the app, right? So the easiest way to think about this is to see what are the type of the resource. So there's an Azure bot, there's an app service plan, there's an app service, and there's language understanding. So if I'm correct, it needs all of these to get it working. So the app ID should be living inside the app service. Yeah. So that's the URL. Should be the same as this one. Oh, yeah. No, it's the other one. Do I have numbers? Okay, so I think go through what I did first in terms of creating the prediction one. So I think some of you guys got stuck, so you guys missed it. So what you want to do is go to click create language understanding, right? And you will click create. So I think some of you guys couldn't create the authoring, even the authoring and prediction tool. So if that's the case, you just click both, and then click the subscriptions again, and choose your resource group. That's like double check if you guys all like basically have nothing in your resource group right now. So if that's the case, you want to click both and just review create. So this one you want to name it tutorial bot, right? And then authoring location, Australia East, authoring price F0, Australia East, I don't know. And then, yeah, this shouldn't be grayed out for you guys, but it's grayed out for me because I created it just now and you can only have one at the time. So yeah, select F1 as well. And then you want to click review and create. Let me know how you guys going with that before, and then you guys want to connect it here by adding it. If you guys already have your resources provision, you want to go to that provision one, the authoring one, go to keys and endpoint, and you want to copy the key. You go to publishing profile, and then edit publishing profile, and add your key. Please don't use my key. Or maybe we can if that's our last resource, but. Okay. So technically, it's importing. I'm just gonna try my one just in case, like my one is actually just broken as well. Okay. Okay. So my one actually works. Cool. Hi. Help. Cancel. Yes. Cool. So that works. So hopefully, if we can recreate all of those resources that you guys couldn't create through the composer, we can actually get it working. Okay. All right. Is that it for now? So did you guys finally able to create your authoring stuff through Azure? Bill, wait, when did you get it?
Oh, that was like the very first.
Oh, no. So one more thing is I'll show you something.
Holy shit. Oh my god.
You want this one as well? Just type in list resource, your list prediction, put it here, and this will be the name of your prediction resource. Yeah, so there's the authoring one and the other one, right? It's the other one, the name of the other one. Oh, it works? Okay.
I just pass it back is something. I think because the syntax is too difficult, for example, I have syntax.
It is fine. We will handle that later. Because we might be short of time later. Yo, so you want to add this service resource, and it's gonna be the name of your prediction resource. So it will be, I think for your one, this is the MSA bot. Yeah, just the MSA bot. Yes, you have to add this line, unless there's already that line there, but I don't think so. Yeah, just at the end. It's fine, the same. Okay. I think you guys do that. All right. Now we're actually gonna do some work. 1 hour in, by the way. Okay. So what we're gonna do now is we're gonna create a new dialog. I'll see my documentation just so in case. Create intent and entities. Fetch anime? Okay, so I'm gonna explain it again. The intent is a way for the bot to recognize what you want to do, right? So for example, I have an intent called fetch anime quotes, right? So for whatever you say, in this in which you categorize it as fetch anime quotes, the bot's gonna recognize it as like, oh, you want to do this, right? So for example, I have these like lines of code. Tell me a quote from blah blah blah. Can you quote blah 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 for me? What is a famous quote for blah blah blah, and so on and so on. So I'm gonna tell the bot to learn that these lines are supposed to be matched to an intent called fetch anime quotes. So let's do that. So if you go here, you want to add a new trigger. All right, a new trigger. So what is the name of this trigger? Fetch anime quotes, right? And you want to, oh, I can just copy paste this. Easy. And you guys have to type it. Or you guys can just go to GitHub and just do that. And submit. Cool. So now, as those codes, we create a new intent called fetch anime quotes. If you have noticed that there's, okay. So this is our entity. So entity, let's say entity is like our function parameters. So for every time, well, it's actually a certain phrase or word in your sentence that you send to the bot that can be categorized as a variable. So for example, in the line, tell me a quote from Shingeki no Kyojin, I call that Shingeki no Kyojin as this an entity of anime. Yes. So when you do that, it will hopefully recognize.
Why do you have to specify the name of the animal?
You don't have to, but like what we will do later on is that we will use that that entity that we recognize to call an API, right?
Is learning for case sensitive?
No. No. So it will be, Lois should be intelligent enough to be able to kind of learn like similar sentences, right? But like very different ones, let's say from what is a famous quote from blah, 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 and like, for example, just quote, it might kind of be not smart enough to tell whether or not they're the same. But for example, if it's the word order is the same, let's say, show me a quote from Berserk, and then, can you show me a quote from Berserk? It's probably smart enough to know that that's the same intent. But yeah, there will be like some edge cases where basically the more sentences you put here, the smarter the bot will be. So this should be like reasonably smart enough. Cool. I think what we're gonna do now is we're gonna create a condition. Right? So if you click at that small plus button over there, you can create different things. So the condition will be, we'll run an expression. And the syntax is a little bit weird, but basically you can look at here and see what kind of syntaxes can you actually guess do. So the x1 is actually variables, and the fx is the functions. So I'm just going to search for exists, and then that expression, we will go. So if you see at anime, this will actually recognize the intent because we're living in this dialogue. The whole dialogue will understand what is defined here, because we already defined that we have a variable called anime that we will get once we get the response back from from Lois. Then we will know that this dialog will actually have this @anime variable. Later on, we actually want to set our own variables. But for that specific one, we can immediately get it from the return value, basically. So for now, let's try something simple. Let's try, say, send a response and saying, I recognize the name, right? That anime, right? I recognize that anime. Can't even type. I recognize that anime. And then if it's false, send a response. I don't recognize that. So even though that's what I said, what could actually happen is that it just doesn't recognize the syntax of words that you have, and that's why it can't actually like takes the actual name of the anime you put in. Okay, so we restart. Sorry, it takes quite a while. Let's see what we're gonna do. So yeah, you can also like set a property. Will basically just make sure that this variable will live in this so long as the dialog live. You can also override the variable. Basically, it's just like programming. on like C# or anything, because like actually the backend for this is C#, unless you choose something else. You can also send a response. You can actually also form a response by using concatenation. You basically can form strings together and use variables to add them. So let's say fetching quotes from, and you use the string construction to create that. So yeah, let's actually try that. So we got that working, and I'm gonna open a web chat. Get quote from. What do you guys want? Bleach? Nah, Bleach. I don't recognize that anyway. Okay, it doesn't recognize that. So, does it recognize Naruto at least? I don't recognize that. I doubt. Maybe it's just not working. All right. Have I put a condition? Exists at anime. Everything based on whether the anime is other sentence. Next up, we want to use it. Okay. The easiest way to test this is just to do the exact one, because if we can't recognize that one, as probably something is wrong. Quote def note. Yeah, okay, so it does recognize it. It's probably just, it's just not smart enough to code Naruto. Let's see. Oh, it does. Yep. Yeah, so it's probably just my syntax was not nice. Yeah, it should be able to. Yeah, it should be able to recognize different lowercase or uppercase. So let's try an anime that's not in that, right? Quote, spirited away. Spirited away. Oh. Get me a quote from Spirited Away. Sprite? Okay, so yeah, I think it's just some of the syntax of your words confuse the bot. But that's something that you can improve by giving it more example sentences. Cool. So now that we know that we can actually recognize some stuff, I will actually just like teach you guys how to set a property anyway. So we can do, if it's true, we can manage property, set a property, and we will call this user.anime, and then we will set the value as anime. Hopefully that's the correct syntax. Nope, it's equal anime. And now, instead of just saying that, I want to say fetching use that $, hold up. Okay, let's get copy that. Fetching quotes from that. So that's just the string construction. So it should be inside quotation mark. That's still going to be a quotation mark, but the $sign and then squiggly brackets user.anime is just the same one as the property that we set here. Cool. So let's try that again. All right, I'm gonna test it in here. Oh, I opened it again. Delete it. Get quote from Naruto. Okay, fetching quotes from Naruto. So now we're actually able to see that you can actually form strings. Next, we already have that. Testing your bot, we already have that. Now, we want to do something more interesting. We want to actually call an API and be able to get that. So there's something called access external resources and send an HTTP request. So I think it's a GET request. If I'm not mistaken, just copy that. Return results. Okay. So remember that that will be your user, your global your variable as well, your property. In that way, so this API actually just gets you a quote from an anime. And then result of property actually store that JSON response from this HTTP method. Yeah, and then you can use it. Is anyone having trouble? Okay. So we have that. Send a response, fetching. I gotta call that. All right, so next one. Because the return value of the HTTP request returns like 10 quotes, basically, we want to return more than one, right? So what we're gonna do is we're gonna set a property and then set a render number. So user dot random number, and then ren 0,9, and then you want to send a response, right? And then you want to paste this. Okay, I'll restart it. Cool. So that works. It can fetch a quote from Naruto, and then it returns it. Do you guys have anyone have any troubles getting there? So there's the next part. So there's the next part of like, because you need to build it first, right? So what you did just now is you just send the HTTP request. But you haven't done this, so it won't show up. But yeah, so basically you want to send a response, and you want to build the string basically using the response. Yeah? Makes sense, right? Yeah, because the response, in this one, the response actually gets stored in this variable called turn results. You can put it in any variable. I just put it there, or it's just the default value. Yeah, this is the default one. You also want to make sure that you set this property called user.random number, because the HTTP request returns a JSON object, and it also returns more than one quote.
So we just randomly.
Yeah, randomly pick one. I think it's done. Okay. Okay, so it is done. You wanna? Okay, so Michael's gonna explain you guys how to connect them to Telegram and actual working stuff.
So we can build a Telegram bot.
Yep.
Use both of them.
Okay, so I'm just going to quickly show you how to connect your bot to Telegram or basically any other social media kind of thing. So like Messenger or Microsoft Teams. So if you go into your resource group and then under Azure Bot, you can find channels under the settings. And if this, right, if you do this, so you basically are shown all the options where you can actually connect your bots. So right now we're running it straight out of the composer, but we can connect it to any of these alternatives here. So basically it makes it much more simple to actually, or accessible for your bot to be accessed from different platforms. So I'll go ahead and show you how to connect it to Telegram, and you guys can work out the rest from there. So, oh God. Pardon? It is not up yet, but for now, even if you want to, you can actually find it online. So if you search up bot framework and then Telegram, you can actually find it easily. Otherwise, it should be up by tomorrow. It should be up by tomorrow. Otherwise, search it up. So. Oh, so. Yeah, so you have your resource group for your bot, right? Which holds all the resources for that bot you have created. The Azure bot.
I think some of you guys might not have created those ones before.
And then you just open up Azure bot here. And then on the side, you should see channels. And then you have all the options there.
There's a free one, but default is not free.
Oh, there's a free one. Why don't you use Telegram
Wait, pardon?
That is a very which one.
Is it web app one? I'm not too sure because I'm using it on my laptop and I was just using the application.
You can just use Telegram web.
Okay, make that faster.
You go to device, scan QR.
Yeah.
Doesn't really work for me. I made it in like an hour. So it's just HTML. I mean, I hosted the website somewhere.
Okay. So I think that the easiest way you can do this is if you search Telegram bot father, and this is how you create the connections with Telegram.
Yeah.
You should just go for father. You just assign a channel to Telegram.
Yeah, and then you just start one. So just open Telegram. And then they'll just open it up, and then you'll just get a conversation with it. So, this would be the initial conversation you have with it, and then you'd obviously go start, right? And then it gives you all the options here, and then we can create a new bot for it. So that creates a new bot. Then this is our key that we need. So we copy this key, and then we would go back to Azure. And then we basically just chuck that into here, save it. Yep, okay. Go here. Is that working? So it's basically as simple as that. So once you've connected the access token to your Azure, it should be easily accessible through here. So it basically functions as what you've been doing inside of the bot framework composer so far. So what are the contexts?
It will be. I mean,
This.
the more you do, the better you are. Because it's not, you're going to get a job. So you do everything.
Oh. There's one working. Wait, Saki, your bot's broken. But if it works correctly, it should be just as simple as that. So just like attaching, getting the token from the bot father, putting it into Azure, and then you should be able to easily communicate with your bot.
I think it's, we need to publish my bot first.
Oh, is it not even published? Okay, so you can do it.
Hopefully that's why. Oh, what are you doing?
Oh,
Yep, just publish it.
that's going to take a while.
You can zero. There's a free one, but the thing is, it always default to the standard one. So what's the difference between the free one and standard? The different one is the amount of calls to the bot you can have per month.
And how much 10K? For 10K calls?
10K cores for the free one, right?
Yeah, and 5 calls per second.
That's enough.
Yeah, actually might be. So can you wait that because of the bot to tell you readability score? That's what we kind of want them to do, right? If they're doing all of this.
You want to move it there? Oh, okay. I can show you.
Why are you using so I can't make it something.
So there's an annoying thing about bot framework, this version right now. Because basically, right, you can't really move stuff, or you can't copy paste stuff as well, right? So this node, if you made a mistake and you put it here instead, like there's no way to move it in the GUI at least, but you can actually show code, and you can actually like try like making sense of it, and then like copy paste it and move stuff. But yeah, unfortunately, that's what you have to do for now. Microsoft is working more on this, hopefully. Hopefully. But yeah, for now, that's what you need to do. Huh? Oh, yeah. Oh, it's done? Yeah, you can try.
What do you?
Hopefully it works now. I don't know.
It should just work. Hopefully.
Oh, yeah.
Okay. Is this right?
That's kind of right, yeah.
That's the right output.
Yeah, try get Naruto. Get quote from Naruto.
Get quote from.
Yeah.
Works. Oh. What was the one that worked?
Huh?
There was one that worked before, wasn't there? Was it like just fetch Naruto or something? There was one that worked. I don't remember which one it was. This one?
Yeah, you can try that one.
Or not?
Or not.
I mean, it's working partly. No?
Okay, can we see the call stack in Telegram? Is there a way to see that?
You cannot. Oh, there we go. This was old, right? No, that's fine. I think.
What time?
56. Oh, maybe. I think it's got an error in it somewhere. Nope. Is it showing on here? Did I close it? Where did it go? I mean, I guess it's partly working, but it seems like there's a bit of an error somewhere. But otherwise, the main point is that you can basically simply make your connections to different platforms by just taking the access tokens for each thing and just connecting it into Azure. So that's pretty straightforward, and that's the main point to take from this. So yeah, we're basically done for today, are we? Yeah. Do you have something to say, Ravindu?
And
Yeah.
thank you for coming, everybody. If you do have any questions about the assignment, let us know. We'll be around for a while. And otherwise, hit us up on Discord and Facebook and other places. Or email David.